multiplication of a vector by a scalar, basically the magnitude is changed. If the scalar is negative, it can change its direction to the opposite direction, but the resulting vector after the multiplication will still be parallel to the original vector. Okay, the first one here shows that it is distributive. So scalar multiplication is distributive over vector addition. This is commutative for scalar multiplication. And the last one's distributive again, but this time vector multiplication is distributive over scalar addition. Okay. Why is this important? It allows you to do a lot of vector algebra with vectors. We're going to see some examples in a bit. Here, we're going to do geometric. 2v is twice as long as v, but in the same direction. So let's see, 2v would look like this. Same direction, twice as long. Whoops, that's not twice as long. Let me fix that. 2v, so twice as long. There we go. It's 2v. Negative 3v is 3 times as long, but it's negative, so it has to be in the opposite direction. So 2 diagonals, 3, 4, 5, and 6. Right, so 6 diagonals worth of length, I guess you could think of it as maybe. Negative 3v. 1/2 of v. 1/2 of v. So like that. Negative 1/4. Even shorter, the opposite direction, negative 1/4 v. That's example 1. Given a is 2i minus 3j plus k, and b is negative I plus j plus 2k, write the following expressions in terms of the vectors I, j, and k. So the first step is I would just write down what we have for those three components, if you like. There's vector A, just writing down what they have there, plus negative I plus j plus 2k. Now, just like with regular algebra, clearing the brackets, you have to look at what's in front. And what we have in front is just a scalar of a 1 or a positive 1. So really, there's nothing to do to get rid of those brackets when we're adding. So we have 2 i's minus 1i is just 1i, so we just write I. Then we have negative 3j plus j, negative 3 plus 1, negative 2 j's. And for the last term, we have 1k plus 2k, that's positive 3k's. Okay, I minus 2j plus 3k. So again, start off by writing it out. So 2 times a, 2 times I, minus 3j plus k, minus 3, negative I, plus j, plus 2k. All right, so I'm going to do this in one step. You can do it in multiple steps, just like you would if it were x, y, and z or something in regular algebra. That's 4 i's. Negative 3 times negative, that's plus 3, so 7i vectors. Negative 6j minus 3j, negative 9j's. And finally, we have plus 2 minus 6, negative 4k vectors. And in the next video, I'll explain the special meaning for I, j, and k. So you might need a little extra space. I'm going to add a page in right now, and I'll show you on the next video.